So we shall continue from where we stopped. Then we had finished part 1. And that's what we had obtained. Then we had started on part 2. We have said we obtained the working value first. But the question said minimum value of A minus B over C squared. So how are we going to manipulate that to get the minimum value of that expression? First of all, we obtain the working value. So the working value is 0.1749. So what's the minimum value of that? The minimum value of that is you get a value less than that. So we are going to look at all the values given, all the variables A, B, and C, and gauge and determine how we are going to minimize each and how we are going to manipulate those to get the minimum value. So the minimum value there is I have to look at the signs first. They will help me know. To get the minimum value, remember B is negative, and remember you're subtracting B from A. So to get the minimum value, therefore I have to make A, since A is positive, I have to make A less positive, and I have to make B. I have to make B less negative. I don't know if you get that. When I make B less negative, then I'm increasing B. So when I increase B, that means I'll be subtracting. When I subtract B from A, then I'll get a value that is small. Yeah, I have to make B bigger so that if I subtract, it reduces the quotient, the term A minus B. But if I say B minus delta B, then that means I'm making B more negative, and if I'm subtract from A, I'm getting a bigger value. But I'm looking at to get a minimum value, a small value from what is in the numerator. So I have to make B less negative. I have to make B less negative so that as I subtract, you remember it's going to turn out to be positive. It's going to turn out to be a plus sign. So let me show you, let me annotate a bit. Here, you can see from here, it's going to turn out to be a plus sign. So I have to make B less negative, right? Yeah, so that by the end of it all, it's going to result to me that I'm adding a smaller value to A. I don't know if we get that. So I have that as my expression for the minimum value, A minus delta A minus B plus delta B, or over C plus delta C squared. Supposed to be squared there. I missed it on that step, but then I added it there on the second step. So I substitute respectively. Then I get that. I substitute respectively, then I get my minimum value for that expression. 1.742. That was Roman 2. Then Roman 3, I still have to get the working value. But then again, we have to analyze here. Remember, B is negative. So from the expression 1 over A minus 1 over B plus 1 over C, I have to get the minimum value of that. I obtain the working value 0.8506. So to get the minimum value, that means the divisors have to be as big as possible. Remember, these are fractions we're dealing with. So A has to be big as possible, B has to be big as possible, C has to be big as possible. So to maximize A, I have to add delta A. Then to maximize 1 over B, or to minimize 1 over B, I am going to make B more negative. And if it becomes more negative, then I am reducing the quotient 1 over B minus delta B. So if it becomes more negative, and you remember it's going to cancel out, the plus signs are going to resolve to a positive. this plus sign, this minus sign here, and the minus that will be obtained from evaluation of b minus delta b. They're going to resolve into a positive sign. So you realize you'll have if it was another step, let's say, you realize you'd have 1 over a plus 1 over b plus delta b, yeah, plus 1 over c plus delta c. I'm making the divisors as big as possible, but because of the minus sign that exists between the fractions 1 over b and 1 over a, then that means I have to subtract delta b from b to make that as big as possible. So I have to make it more negative. The more negative I make it, the less the fraction, because it becomes positive due to the influence of that minus sign. So I substitute respectively, and I end up with my minimum value as 0.8480. Therefore, there is a quiz here. It says, given that x is equal to 3.7, y is equal to 70, I rounded off with the percentage error 0.2 and 0.05 respectively, while the number z is equal to 26.23 is calculated with relative error of 0.04. Find the interval in which the exact value of x over y minus z lies. Correct for significant figures. What does this mean? This simply means that we've been given the percentage error. Now remember from our first video, we saw the definition of terms. Remember what percentage error is. You should be able to remember what relative error is. So from those definitions, you can easily obtain the errors or the error bounds within x, within y, and within z, respectively. Yeah. So I'm not going to calculate this, but I'll leave it for you. So you'd have to use that knowledge. You use the algebra necessary to obtain the different errors: delta z, delta y, and delta x. So when it talks about interval, therefore it's going to require you to obtain the maximum value, and it's going to require you to obtain the minimum value. So you're going to obtain the maximum value of the expression x over y minus z. You're going to obtain the maximum value of this expression, and you have to correct them to for significant figures. Get the maximum value and get the minimum value of this expression. And therefore your interval, yeah, you should know how you write intervals. Intervals, you can use square brackets, and here you start with the minimum value, comma, then the maximum value. Or your interval, you'd use the inequalities. So you'd start with your minimum value, less than, then you put x over y minus z less than the maximum value. Yeah, and therefore this is how you state your interval. This or these two values, these two forms, sorry, those two formats. Those are the formats you use to state your your intervals. Yes. Other than that, the rest is for calculation. And please comment if you have not understood or you need more clarity on something.